Right. Hello, everyone. I'm Michael, the CTO of NuCypher, and we're a new way to deliver data in big data encryption without performance compromises or functionality loss, using our proxy re-encryption secret sauce. And in modern organizations, you have to deal with petabyte scale data lakes with thousands of sources inside of the data inside and outside organization, and thousands of consumers of this data, again, inside and outside the organization. And having this all of the data concentrated at one place, of course, brings tremendous business value, but also, it creates a very big risk. In fact, the larger amount of data you collect at one place, the larger the risk is. All the software, of course, has bugs. So inevitably you have vulnerabilities, and if you do, inevitably at some point they will get exploited, and you basically have to work from the assumption that eventually you will get hacked. And you need to build your systems in such a way that they are safe even if they are hacked. And that is exactly where NuCypher helps. So modern platforms for building data lakes, such as Hadoop, they are great for getting business insights out of the data, but they haven't been built with security in mind. And basically, NuCypher here helps to encrypt the data and do it in such a way that there is no single point of trust failure in the system. So there is no single node in your cluster which an attacker could get access to and get access to all of your data. So there is no such thing in here. And how we do that, we embed access policies directly inside encryption, and these access policies follow like wherever the encryption goes, without any air gaps. Basically, there are three main use cases for our technology, and they all, of course, can be used in combinations, creating shared multi-tenant data lakes, enable moving to the cloud, and meet regulatory and compliance requirements. So, and everything is obviously starts with data lakes. So the way we work, every user of the data lake, every employee in your organization, they all have their own encryption keys. Or you can give them the encryption keys. And these encryption keys are not the same as the keys under which data are encrypted, so they never have the golden keys, right? And the most interesting thing is that even system administrator doesn't have the golden key. So in fact, in our case, system administrator doesn't have access to your data at all. He only facilitates sharing data with all the users of it. And you can think of it as just imagine you have a traditional key and the hotel room key. And once your permission to enter the hotel room expires, you get this key revoked. And if you had traditional keys, this doesn't happen. So you have to go through a big trouble. And that's basically, this is how it works in big data security today, and this is basically what we do. And again, there is no golden key, so system administrator doesn't have access to your data at the same time. Of course, many organizations start moving to the cloud, and they think about moving their data lakes to the cloud. And this even makes the problem even more complicated, because there are many like regulatory agencies who are very interested to see your data, maybe without even asking you to show. So they basically the cloud provider could possibly get subpoenaed, and they're allowed to the regulatory agencies to see the data. So you really you don't want your cloud provider to access your data without asking you, and that's why many financial institutions want to always store their encryption keys on premise inside like on-premise hardware security modules. If you do that today in Hadoop, for example, this will actually make it pretty slow, and even slower if you do it with platforms like Kafka. So it's really like the only practical option today if you want to move your big data to the cloud, you want to move your encryption keys to the cloud as well. So this is kind of stops many financial institutions from moving to the cloud. And we actually enable this use case so that you can store secret keys on premise, have your cluster in the cloud, never show your secret keys to the cloud, and still have your cloud processing your data, again using this proxy re-encryption secret sauce, which I will tell later about. Also, to enable moving to the cloud, you should be able to do like regular encryption procedures such as key rotation, which is basically like changing your lock, the lock on your data. And usually it's actually pretty slow procedure. You need to do that. Well, it costs about a day or two of downtime if you have a petabyte scale data lake. And with NuCypher, you can do that in seconds. That's because you can leverage resources of the whole, like all the cloud resources you have access to do this key rotation, and still while being secure. And also, when you move to the cloud, you need to have FIPS compliance, which is basically using HSMs. But yeah, we do integrate with HSMs. Of course, you always, well, often you need to encrypt to just meet compliance requirements. For example, for PCI compliance, you need encryption in transit and at rest. And at rest should go actually beyond full disk encryption. And we definitely give you that. Or like there is a New York DFS 500 rule, which is I think active from 1st of March this year, which forces all the financial institutions to encrypt the data in transit and at rest. So, and it's not only encryption; it's also all the procedures associated with that. So, so we are definitely a good fit for that. And so today we support platforms, we support Hadoop and Kafka, and also just started supporting AWS S3. And later this year, we will start supporting Spark. And for Hadoop, we support Cloudera and Hortonworks distributions, also Amazon EMR, which I will show the demo with. And we can use Apache Ranger or Sentry as a source of truth for your access policies, which we embed inside encryption. And also for Kafka, we actually make Kafka end-to-end encrypted. So Kafka is like a message queue system, and you have multiple producers and consumers of the data. All of the data gets encrypted before it goes into Kafka, and gets decrypted only when it gets consumed, when you actually need to process it. So if your data leaks somewhere in between, like gets saved to disk, for example, it does happen in Kafka. The data is encrypted at this point, and so you're kind of not accidentally writing unencrypted data on disk. And in fact, this is the only way to make Kafka PCI compliant, because there is no, otherwise there is no application level encryption over there. probably can tell a few words about how their base technology works, for which enables all of this functionality. So the base technology for us is proxy re-encryption, and how it works, it basically allows to transform data encrypted under one encryption key to be encrypted under other encryption key without decryption in the middle. So, so for example, when we enable nodes in Hadoop to read your data, the nodes get temporary access keys, which they can decrypt data with. But they are not the same as encryption keys under which data are encrypted. So we create so-called transformation keys deployed at the storage layer. And then the storage layer can transform data directly to be decryptable by these nodes we gave access to. This could be not only the nodes, this could be also like third parties which you can, who you can share the data with. And I guess I can show a quick demo. So basically over here, what we have a Hadoop cluster at Amazon, and there are two users here. The user Mike, which has access to only his home directory and some encrypted folder, right? And this user just puts a file. Oops, probably not here. Let's say in this folder, right? So this user puts a large CSV file to analyze by like some other users, right? So here, this file is encrypted and it gets saved into HDFS. And you can see that this user can definitely read his own file. So let's say something like this. Oops. It's a typo. All right. So the user can read his own file, but if another user who needs to analyze this data, if he tries to read this file, so let's try to do this. Okay. So if the user Hadoop tries to read this file, then actually nothing happens because this user doesn't have access to it. His encryption key cannot decrypt this file. Nevertheless, let's try to analyze this file in Hive. So we're running Hive, and let's try to create a table from this file, from this folder, in fact. So, okay. So let's say create this folder, and let's run some query. Something very simple. So this creates jobs, and so it tries to run the job to run a query on this file, and it looks like this job actually starts failing because there is no access, and we will see it in a second. All right. Okay. Of course, this job failed. So let's try to give access to this user to actually be able to analyze this. We go to Ranger, and we give access to the data encrypted by key with the name mike.ez.key to the user named Hadoop, right? So, okay. So we do that from the UI. And, okay. So, and we've got this permission created. So what happens after this, the NuCypher software looks at this policy, which we create outside the cluster, apparently, and it embeds this policy inside encryption. So it creates a so-called re-encryption key. It gives it to the HDFS layer of Hadoop, and this HDFS layer now can transform data for the user who can work on this data. In this case, user named Hadoop. So let's check if the permissions actually propagated to this user. Yep, so now the user Hadoop can read the data. And now we can run that Hive query which failed. Because now we should have access to the data. All right. Okay. And it looks like we started having succeeded jobs. So okay, yeah. So here is the result. The job actually just ran successfully, and can probably look at the list of encryption keys we have in the system. So we now just decrypted this data with the key Hadoop.local key, even though the data was encrypted by mike.ez.key. And this transformation was facilitated without system administrator being able to decrypt the data. All right. So this was NuCypher, the new, more secure way to encrypt big data. So given that the access policies are embedded in the encryption system, how do you handle changing overlapping access policies after data is encrypted? Right, so basically how it works under the hood, we encrypt different parts of the data under different derived keys, and then when some user asks access to the data, we generate a re-encryption keys from each, the key for each part of the data to the single key of that user, right? So basically, we embed access policies into these re-encryption keys, right? And the keys under which data are encrypted, they kind of stay the same until you do key rotation.
Yeah. Okay. So if you had any other questions, really make sure to see NuCypher at their booth outside.